Hello, hi guys. In this video, we're going to be looking at how to use Laplace transform to solve differential equations. Now, before we solve this question, this first order differential equation, we are going to look at some basic formulas that you need to know when you are solving differential equations using Laplace transform. Now, the Laplace transform of f of t is f of s. Now, the Laplace transform of first order f prime of t is going to be s f of s minus f of 0. Now, now, what this means is simply your first order relating this to dy dx. Yeah, this is simply your first order. Now, for your second order, which can be referred to as d squared y over dx squared, I think this should be common to you, is going to be s squared f of s minus sf of 0 minus f prime of 0. Then the third order is going to be s to the power of 3 f of s minus s squared f of 0 minus sf prime of 0 minus f prime prime of 0. So I'm going to be showing you how we're going to use all this to solve differential equations. Now let's solve this differential equation. F prime of x minus f of x is equal to 2. Now, of course, this is a first order differential equation. So we're going to solve this first order differential equation using Laplace transform. Now, I'm going to take the Laplace of every single term in this differential equation. So it becomes a Laplace transform of f prime of x minus Laplace transform of f of x is equal to Laplace transform of 2. Okay, now Laplace transform of f prime of x. Now if you come back here, you will notice that it's equal to s f of s minus f of 0. Now Laplace transform of f of x relating to this f of t is going to give us f of s. So this is going to be minus f of s is equal to, now Laplace transform of 2 simply gives us 2 over s. Okay, so now we are given here that f of 0 is equal to 0. So anywhere we see f of 0, we replace it with 0. So this becomes s f of s minus 0 minus f of s is equal to 2 over s. Now this is going to become s f of s minus f of s is equal to 2 over s. Now if you notice, f of s and f of s are common. Now bring them out. So this is going to become f of s into, it's going to remain s minus 1 is equal to 2 over s. Okay, so now make f of s the separate formula. When you make f of s the separate formula, f of s is going to be equal to 2 over s into s minus 1. Okay, so our f of s is given to us here as 2 over s into bracket s minus 1. Now this has led us into partial fractions. So we are going to resolve this f of s, which is equal to 2 over s into bracket s minus 1, into partial fractions. Okay, so how do we go about that? Now to resolve 2 over s into the bracket s minus 1 into partial fraction, it becomes a over s plus b over s minus 1. Okay, so now the next thing we're going to do is that we're going to multiply through by the LCM of the denominators. Now the LCM of the denominator here is s into bracket s minus 1. Okay, so we're going to multiply through by s into bracket s minus 1. Now when we multiply through, this becomes 2 is equal to a into the bracket s minus 1 plus bs. Okay, a into bracket s minus 1 plus bs. Now what's the next step here? Our aim now is to find the constant a and the constant b. So how do we carry out that? We're going to say when s is equal to 1, because why are we saying when s is equal to 1? If you put s is equal to 1 here, this is going to become 0. So you're going to be able to find your b. So this becomes, when s is equal to 1, this becomes 2 is equal to a into bracket 1 minus 1 plus b into bracket 1. Okay, now from here we're going to have it that this becomes 2 is equal to a into bracket 0 plus b. Now a times 0 gives you 0, so that gives you 2 is equal to 0 plus b. Now 0 plus b gives you b is equal to 2. So we've gotten b here, so our b here is equal to 2. Our b here is equal to 2. Now we have to get our a. Now for us to get our a, we can say when s is equal to 0, because when we say when s is equal to 0 here, it's going to be substituted here, and then we are going to get our constant a. So when s is equal to 0, so when s is equal to 0, this now is going to become 2 is equal to a into bracket 0 minus 1 plus b into 0. So that becomes 2 is equal to 0 minus 1 gives you minus 1, that's a into bracket minus 1 plus b times 0 gives you 0. So this is going to become 2 is equal to a multiplied by minus 1 gives you minus a plus 0, that still gives you minus a. Now to get your a, you're going to divide both sides by this negative here, so that becomes that a is going to be equal to minus 2. So we've gotten a as minus 2 and we've gotten b as 2. Okay, so now we can be able to carry out our Laplace transform. Here we've gotten that our a is equal to minus 2 and our b is equal to 2. Okay, so now we're going to substitute these constants into this. So our f of s is going to be equal to, our f of s was equal to this, but we resolved it into partial fraction. So this becomes a, that's minus 2 over s, okay, plus 2 over s minus 1. Now we have it to be that f of s is equal to minus 2 over s plus 2 over s minus 1. Now for us to get the solution to the differential equation, we are going to take the Laplace inverse of each terms. So it becomes Laplace inverse of f of s is equal to Laplace inverse of minus 2 over s plus Laplace inverse of 2 over s minus 1. Okay, so now Laplace transform of f of s is going to be f of t. Now okay, sorry, we're dealing with x in this case, so it's not going to be f of t, it's going to be f of x. So Laplace inverse of f of s, now we're moving from the frequency domain back to the time domain, so it's going to give us f of s is equal to, now Laplace transform of this is going to be minus 2. Okay, minus 2, because you have Laplace inverse of minus 2 over s. You can pull out your constant, which is minus 2. You'll be left with Laplace inverse of 1 over s. Now Laplace inverse of 1 over s gives you 1. Now 1 times 2 gives you minus 2. So the Laplace inverse of minus 2 over s is going to give you 2. Not just 2, minus 2 or negative 2. Alright, so Laplace inverse of 2 over s to the power of s minus 1. Pull out 2. Then Laplace inverse of 1 over s minus 1. This is what I mean. I mean that you have Laplace inverse of 2 over s minus 1. If you bring out your constant, this is going to be 2 Laplace inverse of 1 over s minus 1. Now Laplace inverse of 1 over s minus 1 gives you exponential t. Or in this case, since we are dealing with x, exponential x. So this becomes minus 2 plus 2 exponential x. So, or you could also write your answer as f of x is equal to 2 exponential x minus 2. Or you can still write it as f of x is equal to, because 2 is common, is equal to 2 into exponential x minus 1. So this is the final solution to this differential equation, okay, using Laplace transform. I hope you understand that. Thank you.